Okay, here's a big 10-mark function question. Let's start with the usuals. First, it's going to tell us what the input is to a function and ask to work out the output. So what's f of minus 4? Well, f takes whatever you put in and doubles it and subtracts 3. So if f of x is 2 times x minus 3, f of minus 4 is going to be 2 times minus 4 plus 3. And 2 times minus 4 is minus 8. Sorry, minus 3. Minus another 3 gives us minus 11. Then standard function question, it says if the output is 5, what's the input? That's what this question means. F of what equals 5, so we say f of a is going to be 2a minus 3, and that's equal to 5. So we take the output, we make it equal to 5. I could have left it as x, it doesn't really matter. So if 2a minus 3 equals 5, then 2a's are 8, and a is 4. When we do gf of 6, we need to do f first, then g, not the other way around. It's the letter closest to the number that operates first. So we're going to do f of 6, and then we're going to g that. So f of 6 is obviously 2 times 6 minus 3. So that's going to be g of 9. Just put it down, f of 6 equals 2 sixes minus 3 equals 9. So f of g of f of 6 is going to be the same as g of 9. So what does g2 do the input? It does 1 plus the square root of that number, the positive square root. This is a function, so we only get one possible answer. So when you see square root in a function question, you only take the positive value unless it has 1 minus the square root. Okay. Even then, you take the positive square root, you just subtract it. So we do g of 9, which is 1 plus the square root of 9. Positive square root of 9 is 3, so we get 1 plus 3, so the answer is 4. What values of x cannot be included in the domain? Right, when you're looking at domains and you're looking at the numbers that can't be included, the domain is the domain is a set of numbers you can put into G. So are there any numbers that you can't put into G because you won't be able to work out the answer? Well, you can work out the square root of 10, you can work out the square root of 9.6, you can work out the square root of whatever. Things that you can't square root, at least until you get to further maths A level, are negative numbers. So basically, if the thing inside the square root is negative, that's no good. And the thing inside the square root is just x. So effectively, x is not allowed to be less than 0. So I've just done less than 0 and put a big not through it. So if it asks you what values of x can't be included, x can't be less than 0. Incidentally, if it was the square root of something like x minus 1, then it would, as a whole, then it would be x minus 1 that wouldn't be allowed to be less than 0. So effectively, x would have to be wouldn't be allowed to be less than 1. Anyway, the inverse function g, right? If g takes x and puts somewhere, the way we do this is we start by writing, instead of g of x, we write y equals 1 plus root x. So if g of x is 1 plus root x, I've written root 3, then y equals 1 plus root x, and we need to rearrange now to make x the subject. So to make x the subject, first of all, we need to get rid of all the other terms that don't involve x, i.e. the 1. So we say y minus 1 equals root x. And now we've got rid of all the terms that don't involve x, we can square both sides. So we get y minus 1 squared equals x. Now, what you do to y when you've rearranged it is effectively what happens to the inverse, because in the normal function, x is in the input and y is the output. So when we write y equals 1 plus root x, we means that to get the output y, you take the input x, square root it, and add 1. This is saying in reverse, that means if you want to work out the input from the output, you take the output, subtract 1, square the result, and that's x. So that's the inverse. The inverse function, for write it in terms of x, is where you take that value, subtract 1, you square it, and that's it. So to find an inverse function, you write down the function as it is, g of x equals 1 plus root x, and you then replace the g of x with a y. You then rearrange, so instead of saying y equals something, it says x equals something, and then whatever you've done to y is what you would do to x in the inverse, and that's the end of it.